Good afternoon, everyone, and I thank you all for joining me today. And my name is Yuki, and I'm excited to take you on the journey of the world of dark world. And my topic today is DarkMesh, a blue team monitoring tool for Telegram. And before we dive into the technical part, let's take a quick look at our agenda. First, I will give a brief introduction to the talk. Then we will explore DarkMesh, how to gain data in a secure way, and how to turn the message into the thread and article, and how we use the knowledge graph to present it all. And after that, we'll dive into the real-world case study, OpSec and for exploitation. And finally, the takeaway. And let me introduce myself. My name is Yuki, and I'm currently a security researcher at CyCraft. And I recently I graduated from National Tsinghua University, NTHU Taiwan. And I focus on dark web, cyber threat intelligence, and deep learning. And my past research published at HackDo, HitCon, and PyCon. So before we get started, let me ask you a quick question. How many of you have used Telegram? Okay, great. And now keep your hands up. And if you ever join a Telegram group and immediately mute it because the notification were out of control. Yeah, don't worry, you are not alone. I think muting the Telegram group is the first real step to cybersecurity awareness. Okay, so Telegram. You can use Telegram for encrypted communications with others, or the technical learning, news, or even you can create a personal group to use it as a cloud drive. But there are also many dark web and cyber criminal groups that use Telegram as a community, where they publish leaked data, announce attack operations, or interact with other followers. So Telegram has become a major platform for discussing the criminal activities, and they will sell the credential in the Telegram group. So every day, people are chatting in these groups, so generating a large amount of noise. So there's a need. We need to find a method to monitor and organize the conversation data. So we have 3 expected goals. The first one is convert the daily intelligence, convert the conversation data into intelligence. And the second one is design an OpSec pipeline to safely hide in the Telegram, and use the knowledge graph to recognize the threat actors' behaviors. So let's talk about DarkMesh. DarkMesh, which is the system that I present today and for Telegram analysis. So DarkMesh, I split into 3 main parts to discuss. The first part, gain data in a secure way, and we need to privately collect the Telegram group data, and we use a secure OpSec method. And the second part, we propose a method called message to thread to article. And this method will identify the core discussion topics from a large volume of conversation data. And we will rebuild the thread data based on the topic keyword. And finally, rewrite the thread into the topic article. And the third part is knowledge graph. We will display the conversation data in a graph format, integrate the article to the node, and it's finally easier to query and express relationships. Okay, the first part, gain data in a secure way. The first step we need to do is collect the data from Telegram. How to collect data privately? There are 2 approaches. The first approach is use the Telegram API to retrieve the data. But registering for API key need your phone verification again. So if you use the disposable phone number, it cannot be used. So you might need a real phone number to do it continuously. And we won't discuss this for now. The second approach is use manually dump the conversation data in the Telegram GUI. But this method is straightforward. You just open the Telegram GUI and enter the group, then click the export chat history. Then you can download all the photos, videos, and the message data. Okay, let's talk about the Telegram operation security, also known as OpSec. And to avoid exposing your important information, your sensitive data, such as your IP address, your name, your phone number during the operation, we have certain methods to hide your information. The first one is create a fake account and use the technology such as VPN and VM. And finally, the secure app configuration. Okay, let's talk about the advanced OpSec. At DEFCON 30, Sam Ben shares the social engineering method to hide in the dark web. So we can follow his steps. The first step is creating a fake persona. And persona also known as sock puppet, which means the fake account. So we establish a character background and behavior patterns based on this persona. And we use this background story and the information we create, and we can take this data to creating a social media accounts, such as Telegram, Google, or Instagram. And we center around this character. And finally, playing the role of this character well. So the first step is to create a fake persona. It's just like creating a character in a novel or drama. So design a full story of a character is not easy for the normal. So we can use the large language model to help us. So we use LLM to build the persona. I need to create a character and I give it the requirements such as 30 years old male without good childhood experience and complain about everything and enjoy hurting the weak. And he is also a self-learned hacker. So we can quickly have a character profile. And his online ID is no race and date of birth, and even we can have the MBTI and zodiac sign. Okay, so the background story tells this man, Merrick Verona, grew up in a concrete block apartment and now 30. No-Raz is an underground legend in certain corners of internet. And his motto is, if they can defend it, they don't deserve it. And each social media will have its own ID, such as Telegram or Discord, Twitter. So by the way, if the persona has accounts on many social media platforms, it will make people to believe that this is the real living person. So finally, the language style. Weakness is a service I exploit. So this is a very typical persona. So we can have the persona less than 10 seconds. The next step is using VN and VPN. VN, which is virtual machine, and use VN during the operation can protect you from downloading the malicious file. And another advantage of using VN is if you use the Windows OS, running a Linux VN can prevent you from creating the confusion for the hacker. And it's a bit more difficult to identify your environment. So next is virtual private network, VPN. And always use VPN to prevent your IP address and your physical location from being tracked. Okay, so next is the Telegram secure settings. Always turn on the two-step verification. As for the privacy setting section, you can adjust them as you wish. But for the full security, you can set every option to nobody can see it. And if you use the phone version of Telegram, you can start a secret chat with anybody. It will encrypt your communication. Okay, next, you enter the advanced settings. There's a block called automatic media download, and you need to turn off everything. The default setting is on. It's dangerous that you may download a malicious file or pictures automatically. So here's the flow of our OpSec method. Firstly, LLM builds the persona. And we use this persona and the background story to create a social media accounts, such as Telegram or Google. And you might need a phone number to verify it. Next is, it depends on different apps, but in this case, we talk about the Telegram. So we will do the secure app settings. And during the operations, you can use VM and VPN. Okay, so finally, play the role. So you will build a persona and protect your privacy and finally take action. So you can follow this process and stay hidden in a Telegram group and ensure that when you collect the conversation data, you are not easily detected by the criminals. But however, if you plan to use this for the illegal purposes, believe me, the police will find you. Okay, so the second part of DarkMesh, message to thread to article. Okay, Telegram chat logs is massive. Every day you will receive 99 plus, and group chat data can be very fragmented. You will have tens of hundreds of topics are scattered and easily go off track. So it's not easy to find the useful information. So the traditional approaches to chat log analysis, we will use NLP methods such as segmented analysis, keyword detection, and topic modeling. And in recent years, everyone will use LLM, large language model, and feed everything into the LLM and hope the ChatGPT will provide a full story. So they will both face some problems such as lack of the big picture or token usage is huge. So before we talk about our method, let me give you the definition. Message is the conversation data from the Telegram group. And the thread is the conversation data that discusses a specific topic. So thread is a subset of the message. And each thread data is discussing one topic. And the article is based on the thread. So it's a piece of content with contextual meaning and based on the thread data. So the message part, we will do some reduction to remove the noisy data, such as reduce columns, filter by time, and use embedding to filter. And finally, we will use the LLM to provide us the summary and give us the thread topics. In this stage, we'll have 10 topics. And next stage, the thread part, we will use the keyword that we generated to search this keyword and in the original data. And we will calculate the similarity and find the 5 message before and after it. And finally, we can rebuild a new thread. And once we have the new thread, we will ask LLM to answer our predefined questions and based on our thread data. And each data will include its source. And finally, we can have a topic article. And let's take another look at it in a visual way. Let me break it down. We start with the raw conversation data, and which has a lot of fields and potentially tens of thousands messages. And we use some techniques such as reduce columns, filter by time, and filter by embedding. and to have a cleaner and smaller data set. And with our approach, we are able to identify 10 keyword topics, and each topic comes with its own set of representative keyword and original message ID. Using this keyword, we reconstruct the new threads, and each one is a collection of messages and talking about the same topic. And then we take it a step further. We use LLM to rewrite each thread data into a well-structured report and dedicate to that topic. So in the end, each group, we will have 10 topics article that talking about a specific topic. So in the first stage, in the message stage, we will use LLM to find thread topics. Our final output is thread topic, representative keyword, and message ID. So in order to input more conversation data, because every large language model has its limitation. So we did the following approaches: reduce input token, filter by time range, and use embedding to remove. The first approach is simple and straightforward, because in this stage, we only focus on what they talk about. We only focus on the topic. So we only left the date and message, and other irrelevant data, we remove it. And we visualize the number of messages over time as a line chart. We would like to filter by time range. And the time zone is UTC plus 0. We can analyze the active hours of each group and focus on the most active conversations. Next is we use an embedding model to train for the segmenting understanding to vectorize our conversation data. So the vectorized data will store in the database, and we project it into a vector space. So then we can perform the clustering to group similar messages and filter out irrelevant data. So that's our clustering results. Let's explore the results. If we inspect the value of different cluster group, we can find out that the blue dots are the empty value, and the pink dots are noise, which means they are meaningless messages, and purple dots are bot response. So we can filter out this noisy data and get a cleaner and smaller conversation data set. Okay, so finally, we can use the large language model to output a clear topic that describes the conversation data, and a representative keyword and related message ID, and consistently output 3 topics: leak, Taiwan, and Singapore. The remaining 7 topics are automatically generated by the LLM. So we can take a look at the results. You can see the thread 1, the thread topic is data leaks and database dumps by the OpSec and affiliates. And the representative keyword is leak, and the related message as follows. Okay, the next step is to rebuild the thread. We only have thread topics right now. So each topic has a representative keyword, and we search for the keyword in the original data and extract the 5 messages before and after it. And we calculate the similarity of the message. Is it talk about the same topic? Then finally rebuild a new thread that discusses the relevant topic. So there are tons of messages. We have topic keyword in the previous method. So we search for this keyword in the original conversation. Then we take the 5 messages before and after it as the content of the same thread. If the conversation data is still about the same topic, we continue to take 5 more messages before or after it until the discussion is no longer on that topic. And finally, we will have a new thread. And how we calculate the similarity? We use sentence transformer to compare the similarity between topic and n-5 messages. And if the n-5 message discussion is similar to the topic, we append n-10 message to the thread, and until the similarity is below our threshold. And same for the n+5. So our new thread finally will have fewer irrelevant messages, and the thread data is more focused on the same topic. So up to this point, we have filtered out a lot of noise and irrelevant data from our data sets. Next, we narrow down the scope to 10 threads, and with each thread containing data focused on a specific topic. And final stage, we rewrite the thread to an article. We use LLM to help us rewrite the article. We input the thread data and generate the answer based on our predefined questions. And each answer needs to include its source, such as source message ID equals 1, and output in markdown format. So including the source is the most important thing for us, because we can do the fact checking and we can preserve the traceable evidence. And including the source can make your output more convincing, and instead of just throwing the data into the LLM. So now let's take a look at the article results. The topic is Taiwan, and the headline you can see the hashtag #OpsTaiwan. And the time range is from September 12th, 2024 to January 3rd, 2025. And in late 2024, Taiwan faced a cyber attacks and data breaches, most notably ReorgSec and its alliances. The campaign tag as hashtag #OpsTaiwan. So the background of the attack is that they believe Taiwan is supporting Israel and insulting Russia. So they use the distributed denial of service, which is DDoS attack, and website defacement, which is replace the image of your website, and the data breaches. So the group also used custom tools such as Mega Medusa v3.2, and the campaign was highly visible with extensive media coverage and real-time posting by the attackers. So the impact is widespread, extending to many industries and companies in Taiwan, such as financial services, education, and government agency. The attack were well coordinated and multi-vector and highly publicized. And we can talk about another case from a different group called For Exploitation, which focuses on Singapore. The time range is from April 9th, 2023 to November 1st, 2023. And this report examines a series of defacement and cyber intrusion targeting Singaporean websites. And these attacks underscore the intersection of global politics and cyber attacks. And this event also has a name called hashtag #OpsSingapore. And the primary threat actor identified include Anon Ghost, Stark's team, and For Exploitation. And in several cases, database drops were claimed, indicating potential unauthorized access to backend system and data exfiltration. So this incident targeted both public-facing services and community organizations. So we can have 10 topics or more. It's automated. Okay, the final part of DarkMesh, knowledge graph. Why knowledge graph? Because it's easier to express entity and relationships. And it's easier to query and visualize the data. And the message to thread to article result from the previous chapter, we can integrate it into the knowledge graph. And the graph relationship will enhance the confidence of the analyst inference. So the graph, we define a relationship schema, and we pass the data into the graph. And finally, we store the graph into Neo4j and use the LLM to generate the cipher query. So this is the schema of our graph. And let's start from the top. There are 3 nodes: user, messages, and sentiment. So the user sends a message, and this message expresses a certain sentiment. So this relationship allows us to understand the tone or the intent of the person posting. For example, whether the message carries strong hostility and criminal intent or other emotions. Next, let's take a look at the relationships in the middle layer, where we can see this Telegram associated with other cyber groups. We can see the related groups. And the final, at the bottom layer is the final relationship. It shows that a group claims responsibility for attack event. And this event targets a specific victim. So with these logical relationships, we can be more confident in inferring who initiated a particular attack event, and who is the victim. So once we store the data as a graph in the Neo4j, we need to use the cipher query to search and analyze the data. And since the cipher queries can be quite long, so I combine the questions with the predefined prompts and give it the context and the example. So LLM can provide a great cipher query for us. Okay, let's talk about the real world case study. Number 1, RippleSec. At the end of last year, a pro-Russian hacker group believed that the public statement made by Taiwanese politicians jeopardized their interest. As a result, they decided to start a sanction on Taiwan. They launched a DDoS attack against almost all Taiwanese critical industries. So the main attacker includes the no-name 057 and RippleSec. So for this case, we have selected the Telegram group operated by RippleSec for our case today. So what did they say to Taiwan? And this is the overview graph of the Taiwanese victim. So this message all contains Taiwanese victim. So let's take a closer look. The orange node is the user, and this user sent a message. And this message belongs to a group, which is the RippleSec community. And this message expressed the several sentiments. And this message mentions a target. So we can see this user sends a message, and this message expressed successful attack and self-promotion and criminal intent. And all these red nodes are Taiwanese victims. And who are the targets? And this is also all the Taiwanese victims graph, and we take a closer look. Also, the green node is the group, RippleSec, and they claims an attack event, and the attack event is the yellow node. And the yellow node contains the database leak or the website defacement and other attack methods. And they target the Taiwanese victim. So the final victims of Taiwan contains different type of companies such as the education, finance, and government, and much more. So who are they associated with? And this is also the provides an overview of these relationships. And we zoom in to to see the graph. This group, RepaSec, and they associate with many cyber groups. And there are two groups that are interested. The first one is no name 057, and RepaSec and no name 057 are partners. And among their partners, there's a group called for exploitation. And this group who launched an attack against Singapore a few years ago. So all of these partners are pro-Russian hacker groups. Therefore, I accidentally discovered that the related group was attacking both Taiwan and Singapore for the same reason, for the same political reason. So our next case is talk about for exploitation. So finally, if we click the group node, each node contains many attributes that we have parsed, and among them, several are the topic article that we built in the previous part. So it means you can use Graph to search and visualize the message data. Also can have a structured report about this group. Okay, case number 2 for exploitation. In 2023, for similar reasons, many organizations in Singapore were also targeted by pro-Russian hacker group. The attacker launched DDoS and website defacement. And you can see the right picture, which is their logo and image replaced by the attacker. So what did they say to Singapore? And why do we have two graphs? Because this is the official group and only the bot and the admin can speak. So we can have the two graphs that speaks related to Singapore. So here's the graph explaining what they said. So this orange node user, and it sends a message, and this message contains a sentiment. So you can observe that this user has posted numerous messages, and many of which convey a malicious tone, such as seeking attention and political retaliation and threatening intent. So all of these messages mention Singapore. So who are the targets? This graph is presenting who are the targets, and all the nodes are Singaporean target. So we take a closer look. This group for exploitation, and they claims attack event includes the website defacement and database leak. And they target a Singaporean victim. And the victim of the Singapore includes the retirement industry and the tourism sector and even the temple website. So who are they associated with? And basically the same with RepaSec, because they are all pro-Russian hacker groups. And the famous one is the no-name 057 and RepaSec and Eagle Cybercrude and the Stocks team. So the same with the last case. We click the group node, and each node contains many attributes that we have parsed. And among them, several are the topics article that we built in the previous part. And we can have a visual weight and a well-structured reports. So let's make a summary and takeaways. Telegram is an important source of intelligence, and criminals often release first-hand information there. And DarkMesh can quickly generate multiple topic articles and based on the conversation data, and automatically produce analysis reports and present them in the forms of graphs. And defining a meaningful event correlation and preserving traceable evidence is crucial. It can significantly enhance the effectiveness of your inference. So that's my presentation today. Any questions?
Okay. All right. So he asked, where can we get like this tool, DarkMesh?
This tool is not open source yet, but maybe in a recent months. Yeah.
All right. Is there any other questions from the floor? Okay. I'll come to you.
Hi. Thank you for sharing. I thought it was really interesting how you use like LLMs. But I read like that would LLMs have like any problem with hallucinations? Do you face that issue when working on your project?
You mean the policy?
Yeah, so like when the LLM might produce fake data that is not actually part of the source, I guess.
Yeah. If you just throw everything into an LLM, they will, because all the Telegram data might have the hatred messages or the improper messages. So we will filter out the noisy data first, and once we finish filter the data, and we will project it into a vector space. So it will become an embedding. So the LLM will to search for the similarity. So it's not directly read the words, so it will kind of bypass this limitation.
I see, okay, thank you.
Thank you.